Hello everyone, this is Martin. I'm at RapidMiner, and I would like to teach you a bit about text analytics at RapidMiner and of course operationalization. I'm very sorry that we needed to delay this broadcast for a bit, but now we are all set and can go ahead with this broadcast. So what is text mining all about? Text mining is obviously about, text and mining. Um, Most of the data which you have in organizations are in the end written. Can be medical records, it can be damage reports from engineers, it can be social media data, and a lot of various things. And getting insight from this data is pretty valuable. So this is why we would like to have a look on that. How do we do that? We do it a bit on another way than the usual demos would do. We start with the operationalization phase. I designed a RapidMiner web app for you. A web app is a dashboard, and the dashboard is very interactive. It's tightly connected to the data mining or data science in the background, so that you can really communicate with all the data science in the background and deliver insights and drill downs and everything. Why is that so important for text mining? So if you think about what is supervised learning, or what is data mining? It's often supervised learning, which means you predict the future by knowing the past. For example, you have customers who churned, and then you extract the patterns to data mining, and then use those patterns you extracted from the past to predict the future. In text mining, you don't get the truth that often from historic data. In text mining, you often have the truth coming from experts. If you give a patent to a lawyer, he can tell you what's about, or if it's important or not important. If you give a medical record to a doctor, they can tell you what it's about and judge about it. So in text mining, we often use the experience and the knowledge of our experts to get what we call label, the information about the truth. Then we extract the information, the patterns, to predict the future. Let me close this one here for a second, and let's have a look at that dashboard. So I am at RapidMiner server and probably need to, no, I don't need to log in again. And I created this job offers web app. This job offers web app is showing us, first of all, a bit of a summary over our job offers analytics, or about our crawling process. Everything you see here is done with RapidMiner. So we crawl on sources for job offers around data science, around big data, data scientists, data engineers, and all the things around. We put that into a SQL backend. So the backend is MySQL, and what we will do with RapidMiner is going on top of that. And then we get, like last few days, we get a few results from various markets. As I see, I do this for Germany, Spain, France, the Netherlands, UK, and US, and now we can have a look at it. What we'll focus in the first place is on the company tab up here. Of course, we got geographical, where we have a map of the US and so on. But the company tab is very important for us as studio users who do analysis on texts. So let's move over. What do we have here? We see our companies who offer jobs, and we can click, for example, on cyber coders, and then see they search for data scientists, machine learning data, and Python, and then we can see the full job offer and do something with it. That something could be in a sales cycle, to call them, in a marketing cycle to get something out of it, to target them, to find groups of people or persons or things like that. For us, we have a few buttons. It's a technical background. Every button in here and most of the interactions are RapidMiner processes. think about what you can do with RapidMiner processes which are connected to a button click. So the user only sees, oh, well, that's important, unimportant, a recruiter, and then he can mark it also as tracked or the full company as tracked. In that case, it's a recruiter. So let's click on mark as recruiter, and in the background, we store that information and use that for further mining. So we have here an interface where we can show our experts the data, and they judge whether it's important or not. And you can do the same things, of course, for patterns, for medical analysis, damage reports, social media, whatever you want. And we use this expert vote later on to create a data mining model, a text mining model, to predict whether this job offer was a recruiter or non-recruiter. That's our goal for today. You can then, if you think about operationalization, think that further. We have currently, I think, around about 150 job offers tagged, where I sit there and click and click and click. In the future, I won't need to do that anymore. Because my algorithm is already tagging it for me when the job offer comes in, and I only see the non-recruited job offers because I was not interested in recruiters, or I only see the important job offers, all that stuff. And of course, we can do something like, oh, if our algorithm predicted wrong, then we correct it, and every night we relearn that model, and then we get a better model, and every day we get better model, and we have this kind of feedback loop included to go on. Okay, so this is how a user sees the result of our data analysis, of the crawling, the scoring, and all the drill downs, ETLs. And on the other hand, this is a point where we as data scientists get the insights from the experts on the data. Currently, I'm in both spots. So let's move over to Studio. That Studio here. This is RapidMiner Studio, and probably everyone seeing that already got a short look on it. So we released RapidMiner Studio in January. This is the new version, which is, as you see, way more modern and easier to use. I already had a look on the data, as you saw before, and I extracted all of our English, so UK and US job offers who are already tagged. In a real life situation, of course, we would first do a language tagging between Spanish, French, German, and English, and then build one model for each of them. But currently, let's do it only for English. I have here in my repository already the tag data. We could get this now from the SQL database, but that takes 5 seconds longer, so I extracted it. And as you probably know, you can easily drag and drop data sources, but also processes from your repository over into the process. So we drag it in, we get the operator, which retrieves the tag data, and the data comes out of here on the right. So we connect that to the right, the data is retrieved, and then flows through that connection to the right, and everything which is connected to the right will be displayed. We have here the option to run this process, and if we click that one, well, I reduced the data to the most important things, which is the content, which is the full text of the article, including, by the way, the city information, which I strapped off for internal use, and the tag. The tag can be important, recruiter, or somewhere rarely there's an unimportant. For example, web coordinator department, marketing reporting. Might not be the data science jobs we are most interested in. So we would like now to generate a machine learning model to distinguish not between important, unimportant, and recruiter. We could do that, but let's do it binomial first to distinguish between recruiter and important. So, okay, let's go back here. And what we first need to do is to map our words. So we would like to distinguish not about 3 classes, but about 2. So let's use a map. And what do we map? We can use the options here on the right. We do map one thing, the tag, and then we can say, okay, important will be mapped to non-recruiter, and unimportant will be also mapped to non-recruiter. Recruiter will stay the same. If I run this now, then you see that we only get recruiter or non-recruiter, and if I go to stats, then you see that there's recruiter and non-recruiter remaining. The next thing we need to do in order to build a model is to tell RapidMiner, hey, what do you want to predict? In our case, well, the tag column. So you see here down in the lower level, our feature which is called Wisdom of the Crowds. So we have actually, as you might know, a recommender system in place, similar to, hey, you bought X, don't you want to buy Y? We have a recommender system, hey, you used retrieve and map, do you want to use set role next? Which makes it very, very easy to build those processes. In fact, yeah, we would like to use set role. So we can drag and drop that one in to set the label or the content to label, because in our terminology, label is the thing we would like to predict. If we run this process, then, well, it gets green. Green means label, so we are going to predict the tag. Now, having that done, we are in the situation we got some kind of content and some kind of things we want to predict. By the way, we only got 158 examples, so lines in our table. We now need to prepare this unstructured data to be used. How do we do that? The most common approach which we will use is called a bag of words. What is a bag of words? So what we will do is we cut the full text into words and then count how often did a word occur. It's simple counting first. You could say either it's 0 if it does not occur, 1 if it occurs. There are a bit more sophisticated methods around, but in the end, we count how often a word occurs. And you could already think about what could be a word which could be a significant word for recruiter, probably something like client, because recruiters are usually hiring for clients. So if the word client was used several times, then probably it was a recruiter. That's like the underlying principle we will use. How do we do that? Okay, so on the RapidMiner marketplace, you find an extension called text mining, and this gives you new operators. One of them is the so-called process documents operator. Let's search for it. Process documents, in this case, we can do it plain from data, from files, or even from a mail store if you want to crawl, work your full IMAP through, but we will use the one from data. This is in the end internally something like a loop. We go over each of our examples, each of our lines in our table, and do the inner operators on it. As you see here on the small blue icons on the right, this is a so-called nested operator. A nested operator is an operator where you can go into. So let's go inside here. So here comes a document in and document out, and inside we do the pre-processing. As you see, our wisdom of the crowds is already sensitive and only gives us operators which should be used inside. One of them is, of course, tokenize. Tokenize is doing exactly what I said we will do. It will extract the token, so cut into words. So let's do that one here. Document in, document out. And let's choose term occurrences to do the easy count how often a word occurred. If we run this now, we get a way bigger table, as you might see. So in row number 1, the A was only used once, and 7A wasn't used at all, and then we have ABD, AF, AIAA, and so on, and counted how often it occurred. If you go to statistics, then you see that, well, most of the words are used only once or twice. Yeah, there's some, like analyst was sometimes using 3 times, stuff like that. And now, if you look at the table, we got a table which is structured. On that structured data, we can now learn a machine learning algorithm which uses this bag of words, this counts how often something occurred, to predict. This is now like you might have known it from Studio. So we can now learn a model on that. How do we typically do that? Of course, we do that inside of validation. There is a principle of data science that you should never, ever apply a model on the data you've learned on it. Because if you do that, you won't get a predictive value, but only a descriptive one. That's why we should use a cross-validation. In a cross-validation, we split our data into a few parts, learn on some, and test on the other, so that we are very, very sure that we never tested on something we trained on. That is called X-validation, cross-validation in RapidMiner, and is again a nested operator. We can go inside, and on the left part, we can learn, and there are some algorithms which are known to be very strong on text mining. One of them is an SVM. The other, which works quite good, is a so-called knife Bayes algorithm. And you will find a lot on the internet about knife Bayes. So let's use that one. And on the right, we only get the data we did not train on. They would like to apply the model on the data and calculate the performance. Again, we can use here the recommended operators. Now we are done. What we get out here is our machine learning model and a performance measure. Let's first have a look at the model well, we can have a look at both because that's what we would like to do. Okay, what do we get? We first get a confusion matrix. So from all our data, which are in reality non-recruiter, we would say for 49, they are predicted as non-recruiter, and 18 we classified wrongly. For all those who are in true recruiter, we are at 79, we say correctly, they are recruiter. We misclassified 12. So this model already has an accuracy of over 80%. With 80% accuracy, we predict correctly whether our job offer is a recruiter or not, which is already pretty good. And we also get the model where we can see, okay, the word A is used in both recruiter and not recruiter. There's probably the word client inside where we could see something different. Let's move to C, client, A, H, client. And there you see that it's a bit shifted to the right, that recruiters use it tightly more. And this pattern that it's a bit more used is exploited by the method and used to predict. Of course, we can now have a look, and that's the last thing I would like to do with you. Which words are the important ones? There's a full category of operators called weight-by operators, which do statistical tests to predict whether something is important or not. Let's use weight-by information gain. It's using entropy to predict which word is important and which word not. It's an easy measure, but it's usually pretty cool to see. So what do we get if we run this one? First of all, it takes a second to run. And then every word's got a weight. And the higher the weight, the more important was this word to predict recruiter or non-recruiter. So actually, finally, you see words like a or if are important. So I would guess that this one here, a and if are because maybe recruitment or job offers are shorter, and that's why a is more often there. But there's also the word apply, companies, Cybercoders, which is a company which publishes job offers, Kforce as well. So those are words which have some distinguishing power between recruiter and not recruiter. So how could do we now proceed? If we are fine with that model, we could put that one into action and use that one to clear our data first. So we would then set up an apply process, which then checks for if it's a recruiter or not, and then excluded it from the web app, that our users are not disturbed by recruitment offers anymore. Okay, that's what I wanted to tell you about text mining. I am not sure. Let's have a look on rapidminer.com / office hours. That's the format that we are currently running, where you might have watched that one, and then we can go to RapidMiner OH streams. So yeah, probably because of the delay there, there aren't that many questions around. I would like to send you to the RapidMiner forum, so to our community. That's the old link. So if you go to rapidminer.com, there is a community at learning and this board. And if you have any questions around about RapidMiner, please come over there or simply tweet me. My Twitter handle is mschmitz_, and ask your question there so that I can answer them and make you happy. Thanks a lot for listening. That was RapidMiner office hours for this week. Next week, we will have again someone from our organization telling you about cool stuff in RapidMiner. So stay tuned and log in again.